For centuries, astronomers have searched the night sky for celestial objects that might reveal the secrets of the cosmos. Some stars shine brilliantly, dominating constellations with their radiant glow, while others are nearly invisible to the naked eye. Silent wanderers moving through space unnoticed by early stargazers. One such star, a dim, unassuming red dwarf known as Barnard's star, has captured the imagination of scientists and dreamers alike. Despite being one of the closest stars to Earth, Barnard's star remained unknown for most of human history. Its true significance only became apparent in the 20th century when astronomers discovered its astonishing speed across the sky. But the real mystery lies in what orbits it. A world that defies expectations, a frozen, windswept exoplanet that may hold the key to understanding planets around red dwarfs. What makes Barnard's star unique? Could its planet be a hidden sanctuary for life, despite its harsh conditions? And why does this ancient star continue to fascinate scientists more than a century after its discovery? Let's embark on a journey to uncover the mysteries of one of the most enigmatic stars in our cosmic neighborhood. For most of human history, Barnard's star remained invisible to astronomers. Too faint to be seen with the naked eye, it escaped notice until E. Barnard, an American astronomer, identified it in 1916. What he discovered shocked the scientific community. This unremarkable red dwarf was moving across the sky faster than any other known star. Its apparent motion, known as proper motion, is the highest of any star relative to the Sun. Barnard's star shifts by an incredible 10.3 arc-seconds per year, meaning that in just a few centuries, it noticeably changes position against the background of distant stars. This rapid motion suggests that Barnard's star is on a journey, perhaps an ancient traveler from another region of the galaxy, making its way through the cosmic void. At just 5.96 light-years away, Barnard's star is the second closest known star system to Earth, surpassed only by Alpha Centauri. This proximity makes it an ideal candidate for study, especially as astronomers seek to understand the worlds that orbit red dwarf stars. But the true excitement began when scientists turned their attention to what might be hidden within Barnard's system: an exoplanet orbiting this ancient star. For decades, astronomers suspected that Barnard's star might host planets. In the 1960s, astronomer Peter van de Kamp claimed to have detected a massive world orbiting it, but later analysis showed his findings to be incorrect. The mystery of whether Barnard's star had planets remained unsolved until 2018, when a breakthrough occurred. Using precise radial velocity measurements from the Carmines and HARP spectrographs, astronomers detected a subtle wobble in the star's motion. This was the unmistakable signature of an orbiting planet. Named Barnard's star B, this exoplanet is classified as a super-Earth, a rocky world larger than Earth but smaller than Neptune. The planet orbits Barnard's star once every 233 days, placing it at a distance where liquid water is unlikely to exist. Due to the faint light from its red dwarf star, Barnard's star B is a cold and frozen world, with surface temperatures estimated to be around minus 170 degrees Celsius or minus 274 degrees Fahrenheit. If this planet has an atmosphere, it might offer some protection against the extreme cold, but without greenhouse gases, it would be an icy desert, a world of perpetual twilight under the dim glow of its ancient sun. Despite its harsh conditions, Barnard's star B is an exciting discovery. It is one of the closest known exoplanets to Earth, and its existence hints at the possibility of more planets in the system waiting to be found. Could there be other, smaller worlds hidden in its orbit? And if so, could any of them be warm enough to support life? One of the most intriguing aspects of Barnard's star is its age. While our Sun is around 4.6 billion years old, Barnard's star is estimated to be at least 10 billion years old, more than twice the age of our solar system. It formed when the Milky Way was still young, at a time when many of the heavier elements that make up planets and life were scarce. As a red dwarf, Barnard's star has burned through its hydrogen fuel at an incredibly slow rate, allowing it to survive for billions of years. Unlike massive stars that explode as supernovae after only a few million years, Red dwarfs can live for trillions of years, meaning Barnard's star will outlive the Sun by an unimaginable time span. Its ancient age raises a fascinating question. If planets existed around Barnard's star for billions of years, could life have had enough time to develop? And if so, what might it look like on a world locked in an eternal winter? At first glance, Barnard's star B seems like an unlikely place for life to exist. With temperatures far below freezing, the planet would appear to be a barren wasteland, locked in an icy grip. However, life has a way of surviving in the most extreme environments. On Earth, microorganisms known as extremophiles thrive in deep-sea hydrothermal vents, under Antarctic ice sheets, and in frozen deserts. If Barnard's star B has geothermal activity, it is possible that subsurface oceans could exist beneath layers of ice, similar to Europa or Enceladus in our own solar system. Another possibility is that the planet has retained an atmosphere rich in carbon dioxide or methane, which could create a greenhouse effect, trapping heat and making conditions slightly more hospitable. While this scenario is purely speculative, it opens the door to intriguing possibilities about the adaptability of life in the universe. Imagine setting foot on the surface of Barnard's star B. The sky above would be a deep red twilight, as the dim light of Barnard's star struggles to illuminate the frozen landscape. The sun in the sky would be just 1/100th as bright as our sun, casting an eerie glow across the icy plains. The surface would likely be covered in frozen carbon dioxide or nitrogen ice, sculpted by alien winds. The air, if there is any, would be unbreathable, requiring explorers to wear protective suits. If the planet had active volcanism, geysers of water or methane might occasionally erupt from beneath the ice, creating surreal landscapes reminiscent of the geysers on Saturn's moon Enceladus. Would there be any signs of life deep below, in hidden, warm pockets of liquid water? We may not know for certain until we send probes or more advanced telescopes to uncover the truth. Because of its proximity, Barnard's star is an excellent target for future exploration. Several upcoming telescopes, including the James Webb Space Telescope, will study exoplanets in detail, analyzing their atmospheres for signs of habitability. If Barnard's star B has an atmosphere, these instruments may be able to detect water vapor, methane, or even oxygen, potential biosignatures that could indicate the presence of life. Additionally, projects like Breakthrough Starshot aim to develop tiny laser-powered probes that could travel to nearby star systems, including Barnard's star. These spacecraft, no larger than a microchip, could reach speeds of 20% the speed of light, making it possible to send data back within a few decades. Such missions could provide direct images of Barnard's star B, allowing us to see its surface for the first time and determine whether it is a frozen wasteland or something far more mysterious. Barnard's star is more than just a fast-moving red dwarf. It is a gateway to the unknown. It represents the possibility of planets in ancient systems, the search for life in extreme conditions, and the future of interstellar exploration. Though it is cold, old, and dim, Barnard's star and its lone planet may help answer some of the greatest questions in astronomy. Does life require warmth and sunlight, or can it exist in hidden, frozen worlds? What secrets do ancient stars hold about the early universe? As technology advances, humanity is on the verge of unlocking these mysteries. Perhaps one day explorers from Earth will set foot on the icy plains of Barnard's star B, gazing up at its crimson sky and knowing they have touched a world beyond the sun. The night sky has always fascinated humankind. Since ancient times, our ancestors gazed at the stars, wondering about their nature and whether life might exist beyond our small planet. Over the centuries, as science progressed, we unraveled many cosmic mysteries, yet countless more remain unanswered. Among the closest and most intriguing of these celestial objects is the Alpha Centauri system, a stellar trio that might one day become humanity's first destination beyond the solar system. Despite its proximity of just 4.37 light-years, Alpha Centauri remains an enigmatic and complex system, containing at least 3 known stars and possibly several undiscovered exoplanets. Could any of them harbor life? What secrets do these neighboring suns hold? As our telescopes peer deeper into this stellar system, new findings continue to reshape our understanding of the cosmos. Today, we embark on a journey to uncover the mysteries of Alpha Centauri, exploring its past, present, and future as a potential second home for humanity. The story of Alpha Centauri begins not with modern astronomers, but with ancient stargazers who mapped the heavens without telescopes. Visible only from the southern hemisphere, the two brightest stars of Alpha Centauri A and Alpha Centauri B, were observed by indigenous cultures long before European explorers ever set foot in the southern hemisphere. However, it was in 1689 that Jean Richaud, a French Jesuit priest and astronomer, first identified Alpha Centauri as a binary star system. His observations, conducted from Pondicherry, India, paved the way for centuries of research. Later in 1915, the third member of the system, Proxima Centauri, was discovered by the Scottish astronomer Robert Innes, marking a groundbreaking revelation. This was the closest star to the Sun. Since then, Alpha Centauri has been a prime target for astronomical observations. From early optical telescopes to the sophisticated space-based instruments of today, astronomers have sought to understand its composition, its planetary potential, and even the possibility of extraterrestrial life. At first glance, Alpha Centauri appears as a single bright star in the constellation Centaurus. However, it is actually a three-star system consisting of Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Each of these stars plays a distinct role in shaping the system's dynamics. Alpha Centauri A is a G-type main-sequence star, similar to our Sun but slightly larger and more luminous. It shines with a warm yellowish hue, with a surface temperature of around 5,800 Kelvin. Its slightly greater mass means it burns its nuclear fuel at a faster rate, but it is expected to remain stable for billions of years. Alpha Centauri B, on the other hand, is a K-type star, slightly cooler and smaller than the Sun. It emits a more orange-colored light and has a lower energy output, making it dimmer than its companion. Despite these differences, both stars orbit each other in a complex elliptical dance, completing a full revolution every 79.9 years. But the most fascinating and mysterious member of the trio is Proxima Centauri, a red dwarf. This small, dim star is often overlooked, yet it is the closest star to Earth beyond our Sun. It lies about 0.21 light-years from the central Alpha Centauri binary, and takes hundreds of thousands of years to orbit them. Red dwarfs like Proxima are known for their longevity, burning their hydrogen fuel so slowly that they can live for trillions of years. However, they are also infamous for their violent flares, which can dramatically impact any nearby planets. For decades, astronomers have speculated about the presence of planets orbiting Alpha Centauri. Given the system's proximity, discovering an Earth-like world here would be a monumental breakthrough. It would mean that interstellar travel might one day be within our reach. The first significant breakthrough came in 2016, when scientists confirmed the discovery of Proxima b, an exoplanet orbiting within Proxima Centauri's habitable zone. This planet, roughly 1.3 times the mass of Earth, completes a full orbit around its star every 11.2 days. While this sounds promising, Proxima b's environment is likely harsh due to its parent star's intense stellar flares. If it has an atmosphere or strong magnetic field, it might retain conditions favorable for life. However, more research is needed to determine its true habitability. In recent years, astronomers have hinted at the existence of other planets in the system. Proxima Centauri C, a possible super-Earth or mini-Neptune, was detected in 2020, but its habitability remains doubtful due to its greater distance from the star. Meanwhile, speculation continues about whether Alpha Centauri A or B could harbor planets, perhaps even Earth-like ones, though no definitive evidence has been found. Upcoming space telescopes, such as the James Webb Space Telescope and the European Extremely Large Telescope, are expected to shed more light on this question. If a planet is discovered in the habitable zone of Alpha Centauri A or B, it would be the most promising candidate for interstellar exploration. Let's imagine for a moment that humanity has developed the technology to travel to Alpha Centauri. What would an astronaut see upon arrival? If approaching from the outer edges of the system, Proxima Centauri would be the first landmark. It would appear as a dim, reddish dot, barely illuminating its surroundings. As our spacecraft moves closer to Alpha Centauri A and B, the view would become spectacular. These twin stars shine brightly, dominating the sky. If there were habitable planets orbiting them, they would experience an unusual celestial display. Two suns casting golden and orange glows over alien landscapes. If one of these planets harbored life, what might it look like? Would it resemble Earth with vast oceans and green continents? Or would it be an entirely different world, shaped by an environment unlike anything we know? The answers to these questions remain unknown, but with advancing space technology, we might not have to wait long to find out. Alpha Centauri has long been a subject of fascination in science fiction, from books and movies to video games. But beyond fiction, serious efforts are underway to make interstellar exploration a reality. One of the most ambitious projects is Breakthrough Starshot, an initiative aiming to send small, laser-powered probes to the Alpha Centauri system within the next few decades. Using ultra-thin, light-propelled sails, these miniature spacecraft could travel at 20% of the speed of light, reaching the system in about 20 years. If successful, this mission would mark the first human-made objects to travel beyond the solar system at such high speeds. The data collected could revolutionize our understanding of planetary systems beyond our own. Moreover, with advancements in AI, quantum computing, and autonomous spacecraft, humanity may one day send larger crewed missions to Alpha Centauri. The biggest challenges, radiation exposure, propulsion technology, and self-sustaining habitats, remain unsolved. But given enough time, these obstacles may be overcome. Understanding Alpha Centauri is not just about satisfying scientific curiosity. It is a necessary step in humanity's long-term survival. Our sun, though stable, will eventually exhaust its nuclear fuel, forcing us to look outward for new homes. Interstellar travel may seem like a distant dream, but every breakthrough in astronomy, physics, and engineering brings us closer to making it a reality. Furthermore, the search for exoplanets in Alpha Centauri may help us answer one of the most profound questions. Are we alone in the universe? If life can arise elsewhere, Alpha Centauri is one of the best places to look for it. Even if we do not find extraterrestrial civilizations, the study of planets in this system will teach us about planetary formation, habitability, and the delicate balance that makes Earth so special. Alpha Centauri stands as a beacon of exploration, an emblem of our cosmic curiosity and ambition. It is a system rich with mysteries, 3 stars, potentially habitable planets, and the closest stepping stone to the rest of the galaxy. While reaching it remains a formidable challenge, the first steps are already being taken. Perhaps one day, long after our first pioneers set foot on Mars, a new generation of explorers will embark on the greatest journey of all, an interstellar voyage to Alpha Centauri. Whether as scientists, dreamers, or future travelers among the stars, humanity's connection to its nearest stellar neighbor will only deepen with time. The universe is vast, and Alpha Centauri is but the first step. What awaits beyond? Only time will tell. When we look up at the night sky, we see more than just stars. We see history, mythology, science, and mystery woven into tiny points of light. Some stars blink faintly in the distance, cold and ancient, barely brushing the darkness. Others blaze like celestial lighthouses, dominating the heavens with their brilliance. And among them all, Sirius stands apart, the brightest star in our night sky, a luminous beacon that has captured human imagination for millennia. But behind its dazzling light lies a story far deeper and more complex than mere brightness. Sirius is not just a star, it's a double system, a cosmic enigma, and a stellar paradox. It hides a white dwarf, the ghost of a long-dead star, locked in gravitational dance with a shining, massive companion. It is both old and new, radiant and fading, ordinary and extraordinary. Let's travel across time and space to unravel the secrets of Sirius, the blazing heart of the winter sky. and explore the mysteries that have surrounded it for thousands of years. From ancient civilizations to modern telescopes, Sirius has never gone unnoticed. It has been revered, measured, feared, and studied. Known to the ancient Egyptians as Sopdet and to the Greeks as Sirios, meaning scorching or glowing, this star held great importance in many early cultures. To the Egyptians, the heliacal rising of Sirius, when it reappeared in the dawn sky after being hidden behind the sun, marked the start of the annual Nile flood and the beginning of the new year. It was so crucial that entire religious calendars were based around it. In Dogon mythology in West Africa, Sirius was believed to be part of a binary system long before modern science confirmed it, a fact that still sparks fascination and speculation today. Sirius has always been more than a bright light in the night. For ancient astronomers, it was a cosmic marker, a clock in the sky, a calendar for life on Earth. Sirius resides in the constellation Canis Major, the Great Dog, and is often called the Dog Star. At a distance of about 8.6 light-years, it is one of our closest stellar neighbors, which contributes to its incredible brightness in our sky. But brightness is not just about proximity. Sirius A, the main star we see, is roughly 25 times more luminous than the Sun and about twice as massive. It shines with a spectral type A1V, meaning it's a white-blue main sequence star with a surface temperature of around 9,940 degrees Celsius, 17,900 degrees Fahrenheit. That's nearly twice as hot as our Sun. The name Sirius is derived from the Greek Sirios, glowing or scorching, a name it earned not just for its radiance, but for its fiery role in myth and season. But Sirius is not one star, it is two. And the second member of this cosmic pair, though invisible to the naked eye, is one of the most remarkable stellar remnants in our cosmic neighborhood. Orbiting Sirius A every 50.1 years is Sirius B, a star that no longer shines with its own light. This companion was once larger and more massive than Sirius A itself. But it ran out of nuclear fuel long ago, collapsing into a tiny dense sphere, the remnant of a star's final breath. What remains is a white dwarf, about the size of Earth but with a mass nearly equal to that of the Sun. To put it in perspective, a teaspoon of Sirius B's matter would weigh around 5 tons on Earth. Sirius B is one of the first white dwarfs ever discovered, and it was also the first whose existence was predicted before it was seen. Astronomers noticed that Sirius A exhibited a slight wobble in its motion, indicating the gravitational tug of an unseen companion. In 1862, American astronomer Alvin Clark finally observed this ghostly object through his telescope, the same year the U.S. Civil War began. Despite its dead nature, Sirius B is a fascinating object of study. It shines not from nuclear fusion, like regular stars, but from the residual heat left over from its fiery past. Over billions of years, it will continue to cool, becoming darker and colder, fading into a theoretical black dwarf, a state the universe has not existed long enough to produce. Sirius A is a hot, white-blue main sequence star with a diameter about 1.7 times that of the Sun. Its mass is approximately 2.1 solar masses, and its energy output is much greater, yet its life expectancy is significantly shorter. While the Sun has a lifespan of around 10 billion years, Sirius A is expected to last only around 1 to 1.5 billion years in its current state. Inside Sirius A, hydrogen is fusing into helium in a core reaching over 20 million degrees Celsius. Convection and radiation carry this energy outward, causing the star to glow with a brilliant white light tinged with blue. Sirius B, in contrast, is a degenerate object, a stellar corpse made entirely of electron-degenerate matter. Though it's only 12,000 kilometers in diameter, its gravity is intense, and its surface temperature can reach 25,000 Kelvin, much hotter than Sirius A. But without fusion, it is a star running only on thermal inertia. Together, this stellar duo paints a stark contrast: youth and age, energy and entropy, light and shadow. Sirius A and B orbit each other in a highly elliptical path, with an average separation of 20 astronomical units, roughly the distance between the Sun and Uranus. However, their orbital distance varies from about 8 to 31 astronomical units, creating complex gravitational interactions. The precise nature of their orbit has allowed scientists to test predictions of Einstein's general theory of relativity. In fact, by observing the motion of Sirius B in particular, astronomers have been able to detect relativistic effects like gravitational redshift, a phenomenon where light escaping the intense gravity of the white dwarf loses energy, becoming slightly redder. This makes Sirius not just a visual wonder, but a natural laboratory for physics. For years, scientists and dreamers have wondered, could planets orbit Sirius? Could a civilization exist on a world bathed in the light of the brightest star in our sky? So far, no planets have been confirmed around Sirius A or B. However, the intense glare of Sirius A makes detecting smaller objects in its vicinity extremely difficult. The gravitational interactions between the two stars may also make stable planetary orbits difficult, at least within a few AU of the pair. That said, recent developments in infrared and high-contrast imaging are enabling astronomers to look for giant exoplanets in more complex systems. Some speculative claims have been made about faint infrared sources near Sirius, but no credible detection has held up under scrutiny yet. Still, the search continues, and even if planets are absent, the question of life around binary stars remains one of the most intriguing in modern astronomy. Sirius is not only important to scientists, it holds a special place in the cultural history of humanity. To the Aboriginal Australians, it represented a hunter or an eagle. The Polynesians used it for navigation across the Pacific. In Japan, it is known as Alboshi, and in ancient China, it formed part of the celestial wolf. In the western sky, Sirius marks the nose of Canis Major, the loyal dog following Orion across the heavens. On winter nights in the northern hemisphere, it is a dazzling presence, unmistakably the brightest point of light in the sky. 25 times more luminous than the sun, its brilliance undimmed by distance. Sirius even inspired the term "dog days of summer," referring to the time when it rises with the sun, an association born from ancient belief that Sirius added heat to our star, causing the sweltering midsummer weather. Even today, Sirius remains at the heart of cosmic mystery. Some alternative theorists have pointed to ancient Dogon myths and wondered how such early cultures knew of Sirius's binary nature. While the claims remain controversial and unverified, they do speak to the enduring allure of this star system. Modern missions such as Gaia and ground-based adaptive optics telescopes continue to study the Sirius system with astonishing precision. Gaia has provided more accurate measurements of Sirius's motion and distance than ever before, while other observatories search for faint planetary companions or debris disks. Sirius is more than just a star. It is a symbol of time, a cosmic clock, a testing ground for physics, and a cultural beacon that has inspired humans across millennia. It is the brightest star, yes, but also one of the most mysterious. Its brilliant light pierces the cold of winter nights. Its history stretches back into myth. Its physical properties challenge our understanding of stellar evolution. And its future remains uncertain, wrapped in the long timelines of the cosmos. As we look up and see Sirius shimmering overhead, perhaps we are also looking into a mirror, one that reflects not only the nature of stars, but our own longing to understand the universe we inhabit. And somewhere in that longing, in the quiet between stars, the dog star watches.